All right, so welcome to the part three, to part four of the tutorial about the random motion of atoms and polymerization. In this section, we will add movement to the polymers, and also will improve a little bit the interface. So I would suggest to start with the following: declare a variable. So dim. Array size, actually ARR size as long, okay, and put here array, actually let's put this size, and let's set this to 21 because that's what it is now. So another thing I suggest is let's delete this all other macros that we don't use, okay, and also this unrestricted, we need to delete it, we don't need it. So right now we have only two macros, okay. We have the set array macro and the bound array movement. So let's pick up array size is equal to, let's say W, here is W20 minus 1, okay. Actually the array size will be larger, but we will use this array size in all instead of 20 here, okay. So that's why we put it minus 1. So Control C here, you see here it goes to 21, but since now the array is bound, we don't need to worry about this index out of range error we had before. So we can go to 20, Control V here again, and 0 and 0. So let's see, 0 to array size, I don't see any problem, it works. Let's introduce another thing, another clause here, from B2 to V22, okay, this range. So B2 colon V22 clear clear contents. Okay, so it works. Let's put here 10, set, let me see, set array. Why is not clearing oh, it's clearing contents, but we still need to do to remove the color index, okay. So okay, is 0, and also let's remove any border we have. The border is here somewhere, okay. Control copy, and why we did this, because right now is a variable, okay, let's say none. So what we did here, we picked up the largest area, this is what we expect to have the largest, because here you see you have buttons, you have various text, we have parameters. So you will go anywhere between, I don't know, 3 to whatever small size array to up to 21. So on this area we need to do a clear, because if we move this from a large size, let's say 20 or 21, okay, to a small size, let's put here, let's set this to 2, okay. And now let's go to, I'm showing you, let's comment out these 3 statements, see how bad it is without them. So let's go again, 1 here, set, and then put 2 and put this, set this to 10, okay, set. So what happens is this whole array, if you change the size here, it will take care of that size, but it will not touch the big area. So that's why we introduced at the beginning a way to delete the contents, because when we plot polymers, we write a number telling the number of polymers in each cell. So if there's a polymer there or more, also we color index it, so we need to delete the color on the largest array possible. Even if we work with a small array, we need to initially delete the color and also delete the line, the border. If we have a, how to say, we run with a large size, say 21, and we have remaining polymers with borders, with numbers, we need to delete those. So right now I remove the comment, you know, the apostrophe. So now they act, these 3 statements act, and look, okay, so now you have good, it's good. And also we need to go in this area here, okay, and select it and edit, replace. We will replace anywhere 20 in the selected text. We will replace with ARR size. Let me see if this is correct. Let me just take my glasses. Okay, so this seems correct. And then hit replace. Okay, good. So let's try to run this. Okay, it runs. Okay, it's good. Now we make it a little bit bigger. So set and run it. Okay, it runs. Let's stop it, make it even bigger. So 21. Set. It runs. Let's make it smaller, see if it works correctly. Set. You see it works. It deletes everything around here, this area here, and then you can run it. Okay, this is good. So let's do another thing here. A good friend of mine asked me to he said, you know, this doesn't seem really realistic. If you have some kind of solution, some kind of liquid or whatever, gas, and you polymerize, the polymers are not going to get frozen in place. They're going to move just like the atom. So can you make a model? Can you help us with a model? Can you help me with a model that does this essentially? After you form the polymers, they just move randomly like the atoms. So let's look at the bound array movement, and here we have, let's put some comments. This is the atom detection and movement calculation. And let's copy this, copy it here, because I think it ends here. Control V. So this area, wall let's not say bounding, say bouncing. Wall bouncing. So this detects where the atoms are and also changes the atom change matrix, so later you're able to calculate here the new atom change, the new atom matrix. So in order to do to proceed with this adding this movement of the polymers, we need to create two more arrays. Okay, Control C, and atoms change, let's say polymers, and polymers change. Okay, so another thing we need to do, we need to declare those sizes. Control C, and put here polymers and polymers change. Okay, so let's go ahead here. The atom detection and movement, this module will be identical for the polymer movement. So we copy this whole thing, Control C, and let's leave some space so it's very visible. Control V here, and instead of atoms, we say polymers here. Let's copy this and paste it here. Okay, polymers. Another thing, let's look here. We need to, in the set function, we need to also reset the polymers. So we already cleared the area, you know, from all the polymers, but here there's a color, atoms change. Okay, so this is what it is. Control C. So let's put polymers is equal to 0, and also polymers change. Polymers should be 0 at the beginning when you set, and the polymers change should be 0. Okay, and then here we already did this. We changed the polymers change. Okay, and also here there is a, this is the polymerization section. Okay, no, this is not the polymerization. This is final atom position calculation. Okay, and here is clear atom change array. Okay, so let's take this and copy it, and instead of atoms we put polymers. So after After calculating the polymers change, we add it with polymers and find the final polymers value. Okay, the how do you say, the array of polymers, so we know what to display. We will later here, right here in this section, we will display the atom matrix as a color red, and we will display the polymer matrix pixel by pixel or box by box as a number. A move is, they are gonna move, you know, now every frame they're gonna move randomly. A number surrounded by a border. Okay, and so this is, and here on the bottom is this is the polymerization. Polymerization section. This is a comment. Okay, and let's put the same thing at the end here, so with the limit we know where it is. Control C. And this is the polymerization section. Okay, here a polymerization, it seems this is okay, this is almost good, except we're not gonna just display here. We just perform the polymerization, and instead of B offset whatever, we put polymers of IJ. Okay, is equal to polymers of IJ plus that, and also this, forget about this, let's cut it and put it, maybe we'll need it later. Okay, so let's just put it here as a, let's put it as a comment. Okay, we will use it later. So the polymerization section has just this 4 lines. It's a if statement. If atom is greater than 1, so it's 2, 3 or whatever, then the polymers that in that box where the atom is larger or equal than 2, or greater than 1 or larger or equal than 2, the same thing, you take the number of polymers that are there and add the truncated part of the division of that number, the atom number, by 2. So if you have 2 atoms, you add 1 polymer to that box. Okay, and also reduce the number of atoms. Essentially, you leave as many atoms as they were there, divided by 2 the remainder of that. Again, it's not a reminder, like I said in the previous video, is the remainder. Okay, I checked. So the number of atoms will be smaller because each pair will form a polymer and they disappear from this new atom. The new atom after polymerization is smaller. Okay, and now we display this, we display the remaining atoms. Okay, after the polymerization, display display atoms here, and also let's display, oops, not here, let's display polymers. We take this, okay, and okay, also display the number of polymers. Okay, so A equals polymers J comma I. Okay, so let me think. If atoms, okay, that's wrong. Let's take this, else copy. So let's copy this. So if atoms is greater than 0, let's display this. Delete this. Don't mix them together. We display atoms here. Display atoms, and here display polymers. So here we delete this. And let's take this and add it here and say none. So if polymers and the j or I greater than 0, then we do this, put insert borders, and also in the cell write down the number of polymers. Else, if there's no polymers greater than 0 there, we say delete the border, so x9, and also here is equal to this, okay, is equal to nothing. Okay, you can also clear contents. We can run it, see which one is faster. So display atoms, let's copy this, V, and here polymers. Okay, so let's see if it runs. Okay, let's make it, I don't know, 15. Okay, 15, set, run. Yeah, it runs. So now the polymers are moving. Let's stop it and make it a little bit bigger, maybe 20. Actually, yeah, let's make it 20. Atom spacing 1. Set, run. So now you see, before the polymers were frozen in space, and now they move around. Since we started with a very tight atom spacing, you see in some places you have, let's stop it, in some places you have 3, 2, I bet there's even a 4, yeah, there's a 4 here. Let's put less spacing, maybe 2, set this and run it, and you can see, let's wait a little bit, you must be able to see both the atoms and the polymers move randomly. Actually, let's put here 4, okay, 4 spacing, okay, set, and you should be able to see it even better. No, let's have this 6, set. So okay, so a polymer form, you see, is moving randomly in a direction. Another one, the same, is moving correctly. They don't seem to be leaving the surface. Okay, you see more and more are forming, but they are constant. So I mean the constant number. Let's stop this and put make the size 10 by 10 and atom spacing 1. Set, run it till it's done. Okay, till we have no more, we have a full 100% polymerization. We probably have to wait a little bit. Oh, that's it. Stop it. And so we have a really 100 atoms original. We must have 50 polymers. So let's say this is equal to sum of this, and we should get 50. Okay, so we got 50 is correct. So our algorithm works correctly. Okay, thank you for your attention. So there is an error here. I discovered I'm adding this to the end of the video. It's not a big error, it's just comment error. So here is the atom position calculation and the atom change array, and here I forgot to put polymer position calculation, and of course polymer change array, and everything else is correct. Let's just try to set them in a better position. So you have these calculations here, the position calculation for atoms for polymers. You have the polymerization. Both arrays, the atoms and the polymers, interact here. Okay, you take some, for each two atoms you lose, actually you insert a polymer in this matrix. So this is all calculated in the memory. Is not displayed yet. And here you display the atoms as a color fill, red for atoms, kind of yellowish for no atoms. And also you have another module identical with the first one, polymers display. You display the polymers as a border, and inside the border there's a number, the number of polymers. Okay, and now everything should be moving like you see here. Let's say 21 and set, and they move. Okay, so thank you for your attention.